Welcome back. We are now looking at chapter 4, which is about exponential and logarithmic functions. So we will start with the exponential functions, and this time we will start by the graph of an exponential function, and then we will go towards how to evaluate the function or how to um, do some solve some equations with the function. And first we will look at the exponential function and then at the logarithmic function. So what is an exponential function? Basically, an exponential function is something of the type 3 to the x or 2 to the x or 4 to the x and so on, or 1/2 to the x or 1/2 to the x. So think of any number like square root of 2 to the x, that can also be a value. So here the difference between an exponential function and a power function or a polynomial function or monomial function. For example, the difference between x to the third and 2 to the x or 3 to the x. You can compare to any one of these. So what is the difference? The main difference is that in an exponential function, the base is a variable and the exponent is a number. Whereas in an exponential function, the exponent is a variable and the base is a number. Now, this number we will see later on can be can only be positive, because if you have 0 and if you say my function f of x is equal to some number raised to the power 0, then that is not an exponential function, because f2 to the 0 is 1. So no matter what value of x you take, you will get the answer 1, which means this is a horizontal line, which is not an exponential function. Then if we have negative values, then what will happen if you have -1 raised to the power x, then when x is positive, if you make a table of values x, y, so when x is 1, you get -1, and x is 2, you get +1, x is 3, you get -1, x is 4, you get positive. So it will fluctuate between the values plus and -1, so up and down, up and down. So it means we are not getting a smooth continuous function. So that's why we cannot allow the negative value for the base, and then base cannot be 0. So base has to be greater than 1 and base cannot be 1. Okay, so we cannot have a 1 for the base. We will see that later. Okay, now let's focus on graphing the function, the exponential function. So the first example is asking us to graph these functions or sketch the graph of these 3 functions. First one is f of x is equal to 3 to the x. So let's make the table of values for each of them. So x and 3 to the x. So we can start with some negative values and go to positive. So let's start with -2. So at -2, I get 3 raised to -2, which is 1/9. At -1, the value will be 3 raised to -1, which is 1/3. And then at 0, the value will be 3 to the 0, which is 1. At 1, I will get 3. At 2, I'll get 9. Now, if we go further, it will be a very big number, and we don't want to go that far. Okay, we can make this. Let us first actually plot the sketch the graph of this that we just finished. So let me draw my x-axis actually in the middle. You will see why I did that. So in the center somewhere here, the x-axis. The y-axis, sorry, here. The x-axis, I don't need to draw it in the middle. Why? Because you see we are not getting any negative numbers, so my x-axis will be over here. Okay, if we are going to take 1 unit for each, one tick mark, but basically we can do 2 squares to be 1, just to make it more clear. So 1, 2, 3, 4, because we are not going to go too far away in the, so we might not even do the 2 and the negative 2, we don't need to. Okay, so when I graph the function, so I saw that at 0 the value was 1, so the same scale I am going to take on the y-axis, 1, 2, 3, 4, 5, and then we will have a negative 1 somewhere. So when I do the plotting of the points, at 0 we are at 1, at 1 we are at 3, and then at negative 1 we are at 1/3, somewhere here. So you see already I am so close to the x-axis. If I go the negative 2, which is 1/9 and negative 9, so almost I am like on the x-axis. So just be careful. If that is how it is, then don't go further. Just stay above the x-axis. Don't touch the x-axis, and join this with a smooth curve and going up and up and up like that. So it grows very fast. It doesn't turn inwards. It doesn't go like this. It just keeps on going in its direction, up, 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 straight. At 2, yeah, at 2 the value was 9. We couldn't graph that, so we have to just stay with these points that we have 3 points. So these are the 3 points I want you guys to focus for each exponential function. Like we did for the square root, we had for any square root, square root of 2, square root of x, or if you have to graph, you should be looking at what points? The 0, 1, and 4. If you are looking at the cube root, you should be looking at 0, 1, and 8, because cube root of 8 is 2, and cube root will have a negative values as well. So you have to figure out those values. And then here, this is what I'm calling 3 to the x. Okay, now what about the other one? Let us see. Looking at the, let's do the 4 to the x first. Okay, you know what? Here I actually wanted to do 3 to the x. Now we are going to graph 1/3 to the x, but if you recall from your exponent rules, if you have 1/x whole square, then this can be written as x to the negative 1 whole square, which is equal to x to the negative 2. Or if you have 1/m raised to the power negative, yeah, so same thing, either you can have m to the negative x, then it can be written as m to the negative 1 whole to the x. But m to the negative 1 is 1 over m x. So that I can write 1 over 3 whole raised to the x can be written as 3 raised to negative x. Okay, I hope you got it. Okay, let's try this one. So now we have x, and here I have now 3 to the negative x. You can take it, or you can keep it as 1 over 3 whole raised to x. Okay, we do the same thing between those 5 values, and then we will basically just pick the middle 3 because we don't have space in our graph to plot the other values. They are out of reach. So negative 2 will make the function 1 over 3 raised to negative 2, which means 3 over 1 raised to negative over raised to 2. I hope you remember those rules. It's equal to 9. So kind of you will see these values kind of get reversed. So at negative 1, we will have at negative 1 we will have 1 over 3 raised to the power negative 1, which means 3 raised to 1, which means 3. At 0 we will have 1. At 1 we will have 1 over 3. At 2 we'll get 1 over 9. So if you notice, the values got reversed. So let's plot them. So at 0 it's still 1. At 1 it became 1/3. So we are over here. And at 2 it became 1/9. And at negative 1 we have 3. Now we graph it. Okay, so what does it look like? Doesn't it look like we flipped over the y-axis? Yes, that's what happened. If you recall, if you have a function f of x and you do f minus x, what is the graph of f of minus x will be the same as the graph of f of x but flipped over the y-axis. So this is the graph of 1 over 3 raised to the power x, or same thing as 3 to the negative x. Now we will graph the 4 to the x on the same grid. Okay. Why am I doing it on the same grid? Because I want you to compare, do some comparison of these graphs. Okay. Let's pick another color now, blue maybe. Okay, so now we make a table of values again. So negative 2 will give me 1 over 16. Negative 1 will give me 1 over 4. 0 is 1. 1 is 4. 2 is 16. So you see 1 over 16 and 16, those are values I will not plot because they are, 1 over 16 is so small that I cannot even plot it, and it will make us touch the x-axis. And the negative, the 16 value is so far away, and it is out of the bound of our graphing page, so we are not going to bother about that. But we should use the middle 3 numbers to plot the graph. So at 0, the value is 1. At -1, the value is 1/4. So which will be below this value, because remember this was 1/3. So now the value is 1/4. So a little bit below that. And now at 1, the value will be 4. And at 2, the value will be 16. And at 3, the value will be 64, and so on. So too fast. We cannot catch up with the function. Okay, so let's see. We'll go like this. So notice here the 3 to the x and 4 to the x. If you compare them, what is a graph? What do you notice? That towards the negative side, when x is less than 0, the graph of 2 to the x is above the 3 to the x is above the graph of 4 to the x. Whereas to the right of the y-axis, when x is greater than 0, the graph of 4 to the x is higher or above the graph of 3 to the x. And what do you think if I ask you to graph the function 5 to the x? How will the graph behave? Can you see it will be above these two graphs? So it will be something like over here. On the positive side, and below these graphs on the negative side.